Assalamu alaikum.
Walaikum Islam. Can you see the screen?
Yeah, I can see.
Okay, what are the updates from school? They are doing transition or they are over with transition?
No, we're still doing transition. We're actually in the beginning, but she said she'll go through it quickly because she wants to focus on the past papers.
So she is going quicker now.
Yeah, but we won't be doing, we have exams right now, so we probably won't have classes until mid-November. So it's gonna be a while until we're done with transition.
Acha, it means school will not be taking classes. What does this mean?
Yeah, they won't be taking classes because during exams we don't have classes.
Acha, okay, fine. It means that you people are having an exam like proper exam.
Yeah.
So isn't the mock one? Is this? I think it is the mock one, right? There is another mock in February.
Yeah, that's the mock with all the entire syllabus.
Okay, fine. Acha. But they do it like a proper exam and they suspend the regular classes and you people attempt the course every day is only paper, only every day only exams.
Yes.
Okay. And when this type of session is starting, when is the first paper?
We're actually only doing paper 4.
Okay. Paper 5 is not coming.
No.
Oh, that's a good thing. So they are giving only paper 5. What topics they are giving?
The first 4 topics, energetics and kinetics and ionic and electrochemistry.
Oh. And group 2 and transition are not coming.
Yeah, they're not coming.
So should we do group 2 because we have to, obviously the main purpose is our Cambridge, or you want me to we should do some questions from past paper?
I'm fine with anything. Actually, can you do group 2 because she's also gonna bring questions from it in the exam.
Because group 2 is actually connected with energetics.
Yeah.
Good. So let's go for our group 2. We started group 2 last time and we were doing some similarities and trends. We made this one and we said that group 2 is a little chapter, variation in solubility of the sulfates of group 2. I think we were here.
Yes, we were.
So this will be our first heading. This chapter is closely related with energetics and majority teachers give questions from this also because the knowledge is mainly coming from energetics, not entropy, but energetics, pure energetics. Variation in solubility of the sulfates of group 2. You have to give this heading.
Okay. I've copied.
Good. Solubility of a substance is the amount of a solute dissolved in 100 gram of water. This is our O-level GCSE definition, a very nice definition to understand that at a particular temperature, solubility is the amount of solute dissolved in 100 gram of water. Now, we start from this point that solubility is a major issue in our chemistry because when we are making a solution, we need to dissolve it. And obviously, when you see majority salts being discussed in A2 are sparingly soluble. You can say partially insoluble, like barium salts, like lead salts, like silver salts. Now, you have to copy this O-level definition.
Okay. I've copied.
Right. So now make the concept. solubility of the sulfates of group 2 decreases down the group. It means when you take sulfates, and remember the very well known all-time famous sulfate, barium sulfate, many times it has appeared in the paper. They have some favorite compounds. So this is one of them. Barium sulfate is so much insoluble that chemistry says, A-level chemistry says, it is really an insoluble salt. Other salts are partially soluble, but barium sulfate is a real good insoluble salt. So what is the trend? Down the group, solubility of the sulfates of group 2 decreases. You have to copy this.
Okay.
During the exams, if you want any exchange of any class, you can tell me, because obviously suppose you have a other paper tomorrow and you are studying. So this is a possible, because I was thinking majority schools in Gulf side, they start by 10th November and 15th November, but your school is starting earlier, I think so.
Yeah.
So if there is any need, you can tell me whenever you need it, you can tell me on WhatsApp that it's difficult for you to take the class, because obviously if 4 or 5 chapters are coming, everyone knows that past paper is the key. Na?
Yes. Okay.
So we move forward. Look at the salt solubility in gram per 100 cm cube of water. Look at the table: magnesium sulfate, calcium sulfate, strontium sulfate, and look at barium sulfate. Look at the power. Is it extremely small?
Yes.
If you look the label, you can see the power in the case of magnesium sulfate. Look at the power is only -1. And look
Yes.
where the power has reached.
-7.
Yes, extremely insoluble. Why? This is the trend. This, you know very well that in chemistry, when you talk about a trend, when you talk about a trend, you have to understand the reason. You have to understand the possibility of any contradiction. So for every trend, you must remember the trend itself, the reason of the trend, and if there is any contradiction. Down the group, enthalpy change of solution becomes more endothermic. What is the concept in sulfates? Enthalpy change of solution becomes more endothermic down the group. So what chemistry says, if something is getting endothermic, it is getting more feasible or less feasible?
Less feasible.
Less feasible, because exo reactions are more feasible.
Yes.
Now you have to copy this screen.
Okay. I've copied.
Right. Now, there is a subtle effect which we discussed earlier also when we were doing energetics, that down the group, enthalpy change of lattice decreases. The negative enthalpy change, the enthalpy change of reverse lattice decreases. So it favors enthalpy change of solution. Then, in case of hydration enthalpy, it also decreases. One is favors the enthalpy change of solution, but one opposes the enthalpy change of solution. But I have written more effective in the middle column. It means hydration enthalpy is numerically more effective than negative of enthalpy change of lattice. So down the group, enthalpy solution decreases. It means it becomes less exothermic, becomes more endothermic and less exothermic. So you have to copy this screen.
Okay.
Copy it. I'm just coming.
Okay.
Although the importance of enthalpy change of hydration and lattice energy should be pointed out in the form of a Hess's law, the argument is subtle. Subtle means that one quantity is decreasing, one quantity is also decreasing, but one quantity decrease is favoring and one quantity decrease is opposing. And overall, it is decreasing. So when it is overall decreasing, it is in favor of one thing. So this is called subtle effect. The lattice energy of magnesium sulfate is only 500 kilojoule more than of barium sulfate, whereas the hydration is 620 kilojoule more. Now, these numbers tell you the actual story. The difference in lattice enthalpy is 500 and difference in hydration enthalpy is 620. It
620.
means hydration enthalpy is more effective. Look at the sketch. These are the two sketches, and you can see the comparison between lattice and hydration. Hydration enthalpy decreases a bit more. So remember this theory, enthalpy change of solution becomes more endothermic. Now we know from our energetics chapter that actually solution enthalpy becomes from two enthalpies, enthalpy change of lattice and enthalpy change of hydration. That is why we have to consider the two factors separately.
Yes.
Now, give the heading effect of temperature on solubility.
Okay. I've copied.
Enthalpy change of solution may be endothermic or exothermic. This is again from energetics. Enthalpy change of solution may be endothermic or exothermic. You have to copy this.
Okay. I've copied.
Right. We know this equation from the start.
Yes.
Now, temperature versus enthalpy. Exo process is favored by low temperature, Le Chatelier principle, and endo process is favored by high temperature. This is our AS chemistry, Le Chatelier. Now you have to
Yes.
copy this.
Okay. I've copied.
Right. So now can you suggest that enthalpy change of NaCl is plus 5 kilojoule. So when temperature is increased, why solubility of NaCl increases?
It's because the solution is it's an endothermic. So if you increase the temperature, the solution will also increase.
Yes, it will be a favored process at high temperature.
Yeah.
So we got this. Now you have to copy this example.
Okay. I've copied.
Thermal stability of nitrates and carbonates. You have to give this heading.
Okay. I've copied.
The thermal stability of group 2 nitrates and carbonates increases down the group. It means that if you go down the group, the group 2 nitrates and group 2 carbonates become more stable against heating. Thermal stability means that they should not decompose on heating. They withstand temperature and without breaking. So you have to copy this.
Yes. Okay, I copied.
Now, this is the case. Magnesium carbonate, calcium carbonate, as you go down the group, thermal decomposition, ease of thermal decomposition decreases. It means that it is difficult to decompose barium carbonate. It is relatively easy to decompose magnesium carbonate. You have to
Yes.
copy this.
Okay. I've copied.
Generally, strong heating is required to decompose a carbonate. Carbonates are generally very stable. It was a time in the world when carbonates were being used in construction also, like calcium carbonate, gypsum, etc. But now it's a laboratory material also. You need strong heating, very strong heating. So normally they are very stable. So you have to copy this.
Okay. I've copied.
Now look at this screen. It's a high level heating effect. Now look at the temperature, decomposition temperature. Magnesium carbonate decompose on 400, and look at barium carbonate. It decomposes on 1360. It's a very high temperature relative to magnesium carbonate. So what it
Yes.
shows, down the group, it is difficult to decompose. Down the group, it is difficult to decompose the carbonate. All carbonates, when decomposed on heating, make the oxide and carbon dioxide. You can copy any one equation.
Okay. I've copied.
Decomposition temperature, as you go down, decomposition temperature increases. Now, again, this is why this topic is a connected topic with energetics. The features involved in this phenomena are lattice enthalpy. You know why? Because you have to break the lattice when you are when you are decomposing. And the second feature is coming from AS chemistry, extent of polarization. So you have to copy this.
Okay. I've copied.
Now, distortion phenomena, I'm taking it back from AS chemistry. When a small positive ion faces a larger negative ion, it distorts the ion. Remember this feature?
Yes.
This is originally an ionic bond, but if the distortion begins, the negative ion breaks. This is called polarizing effect. The oxygen atom is well on the way to becoming an oxide ion. So this happens to carbonate ion here. Carbonate ion is being attached with a positive ion like calcium carbonate, like barium carbonate. Due to strong polarization, it breaks into O minus 2 and CO2. This is the internal feature. Now look, this happens when a carbonate is going to decompose. This is called distortion or polarizing effect. You have to copy this.
Okay. I've copied.
This is called distortion effect. This is called distortion effect. Now, we are using this point, the negative ion breaks. Now, this is the point here. CO3, when it gets distorted, it breaks into O minus 2 and CO2. This is called fission. So I have to copy this.
Okay. Okay.
Now, this is the real carbonate case here. Magnesium carbonate first get distorted. The magnesium ion is capable of distorting, stretching out CO3 minus 2. And after being stretched out, magnesium took O minus 2 out of it and throw away CO2. It's a very interesting type of decomposition. So it means that this reaction needs a distortion first and then decomposition. So this is a very important understanding. Then why down the group this process become less feasible. Mg2 plus is very small, but as you go down the group, as you go down the group, the size of the positive ion increases. So what happens when you see now that the positive has grown up? So now distortion cannot occur in case of calcium. Calcium ion is bigger than magnesium, so less distortion capability. So as you go down the group, the positive ion gets bigger. So its ability to distort, to stretch out the negative ion, that ability decreases.
Yes.
Now you have to copy this.
Yes. I've copied.
Right. Lattice enthalpy of magnesium oxide is greater than magnesium carbonate. One point is here. Now, as I mentioned, there are two features to discuss. One is lattice enthalpy, and second is polarizing or distortion feature. Now, look at this point that a magnesium oxide has a greater lattice enthalpy than magnesium carbonate. So this conversion is feasible because you are going towards a greater stability. Chemistry says all reactions occur naturally in the direction of increasing stability. All reactions proceed in the direction of increasing stability. That is why magnesium carbonate is ready to decompose and become magnesium oxide.
Okay.
You have to copy now this.
Okay. I've copied.
Now you look at this distortion feature and then you see the oxide is produced. If the positively charged ion is not sufficiently small, then the negative ion, no polarization occurs, so no distortion occurs. Distortion is necessary for the decomposition process to proceed. Now you have to copy this.
Okay. I've copied.
Now this is the calcium carbonate. Now we summarize this concept. As the positive ion grow bigger down the group, it means that what happened, that the ability of distorting the negative ion decreases. So you can say that the decomposition probability decreases. So this is the summary. You have to copy this.
Okay. I've copied.
Group 2 nitrates show a similar trend in thermal stability. It means that like carbonates, they also show a stability down the group. You have to copy this.
Okay.
Now, magnesium nitrate, when you heat it, it will form magnesium oxide, very similar to the other one, but the product contains two extra products like NO2 and half O2, the approach is the same. NO3 minus 1 distort by Mg2 plus, and it becomes O minus 2. And this distortion is the reason for this decomposition. Now you have to
Yeah.
copy this screen.
Okay. I've copied.
So this is the concept of thermal decomposition, that the ion breaks and it turns into a smaller ion. Now this was chapter 2, a small chapter actually. And you can see your book, and you should see that